Welcome, everyone. My name is Tracy Fitzpatrick, and I'll be your moderator today. Thank you so much for joining us here at NetCom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. And we're very excited to host today's webinar, Cisco Enterprise Networks, Learn How to Implement and Configure OSPF. Presenting today's topic will be Talib Bakhtiari. Talib is a certified Cisco systems instructor and a NetCom learning subject matter expert. He's an IT veteran with over 24 years of specializing in the data center, security, and service provider network infrastructure. With a key focus on learning-centered content quality, Talib has provided expert-level training to learners globally and has helped them gain proficiency in Cisco technologies, network administration, CCNA, and much more. Now, please bear in mind that this is an overview of a very robust topic. We do offer a collection of technical and training and business courses that can be tailored towards your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. NetCom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adopting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. And today's presentation will be from the networking practice area. NetCom Learning offers a comprehensive training portfolio for all types of network courses, which you can check out on your screens for our upcoming classes and training. Private training is also available to teams, which the learning plan can be customized to the specific needs of the audience. You can also access a variety of marketing assets, such as the free 1-hour training, free on-demand training, and blogs by clicking on the available webinar handout. These offerings can be found with a simple search on our website at netcomlearning.com. So why should you attend this webinar today? Well, in the webinar, you will learn to master Open Shortest Path First, or OSPF, designed specifically for IP networks. Also, we will learn how to configure the OSPF dynamic routing protocol from start to finish for both IPv4 and IPv6 and so much more. And finally, I'm going to pass this over to Talib, who will be presenting today's topic. Okay, Talib, you are live. Go ahead.
Okay, thank you very much, Tracy. So guys, now we are starting our lecture. So we're gonna talk about how to configure OSPF. You know, OSPF is very popular protocol when it comes to routing. OSPF is #1 protocol popularity wise, because OSPF is actually a standard protocol. OSPF work with Cisco devices. If you are having any other vendor devices, OSPF actually work with those devices also, okay? And it's OSPF basically deal from medium to large size complex network, okay? And in this discussion, we're gonna go for OSPF configurations. We're gonna talk about IPv6, we're gonna talk about IPv4, and because you know here we have 40 minutes, so I'm gonna give you 10,000 foot overview, and we're gonna discuss base configuration of OSPF, IPv4, and IPv6 point of view. So let's start. Implementing OSPF. Configuring OSPF for IPv4, route redistribution, configuring OSPF version 3 for IPv6, and after that we have a question answer session. Okay, so let's start how we can implement OSPF. We're gonna discuss what is OSPF is, and after that we're gonna go for implementation. Okay, so OSPF is open shortest path first protocol, and this one is link state protocol. Link state means, let's see, what is OSPF? OSPF provide link state informations to other routers. Those routers basically based in different location. Let's see, I have 3 locations: Chicago, Toronto, New York. So Toronto-based router provide link state advertisement to Chicago-based router, and Chicago-based router provide link state advertisement to Toronto-based router, and Toronto-based router share this information with Houston-based router. So we have 3 branches. So everybody basically synchronized through link state advertisement, okay? And that protocol builds and maintain routing table, and that are needed for IPv4 and IPv6 traffic. Let me tell you one thing here. What is a routing protocol? Like, you know, I have in networking world, we have 2 types of protocol. One is routed protocol, which is TCP/IP. TCP/IP, it's like a taxi driver. TCP/IP have a taxi. TCP/IP have, capability. I will move your packet from one place to another. But TCP/IP says, hey, please give me address. Please give me a route. So then I can move one packet from one place to another place. So that's why we have a routing protocol. And why OSPF is so popular, like I mentioned before, it's a standard protocol, work with Cisco, work with any other vendor. So OSPF basically provide routes, provide addressing. So then taxi driver, which is TCP/IP, will take you to your location. Let's say if you want to say, I want to go to my place, hey, what is your address? So then you will tell address to your taxi driver, and this will take you to one place. So TCP/IP, it's like a taxi driver, and OSPF will provide routing, routes, addresses. So that's why routing protocols are very important. Maybe you have a 3-branch network, or you have 3,000 branch networks. OSPF will take care of your networks. And OSPF is very capable, especially if you are having a huge, big network, North America, Europe, Asia, Africa. So OSPF can handle very easily, okay? So here, we're gonna talk about both version of OSPF. Both are open standard, and we're gonna use with various devices, okay? What about shortest path first algorithm? This shortest path first algorithm developed by Dijkstra. That was scientist and mathematician in 1956. And that's why sometimes we also call it Dijkstra algorithm, okay? And OSPF provides very fast convergence. In OSPF, we use triggered updates, incremental updates, because in OSPF, every router have a complete picture. So that's why we have very fast convergence, okay? In OSPF, we do advertisement, okay, link state advertisement, which is called LSA. And LSA actually synchronize your route information with neighbor routes, and neighbor route information with your router. Let's see, you are in Chicago and you have a neighbor based in New York. So how we can exchange information? So sometimes people are asking, hey, Chicago and neighbor in New York, like I'm talking about routers, neighbor perspective. One router based in Chicago, one router based in New York, and they are connected through service providers. So these 2 neighbors router, once we establish neighbor relationships, if I have any routes available in Chicago, I'm gonna share with my router, which is based in New York, and New York based routers share routes with Chicago based routers. And once we synchronize our routes, like I have 5 routes with me here in Chicago, and we have 10 routes in New York. So we have 15 routes, and those 15 routes we synchronize with Chicago and New York. Now everybody have those 15 routes information. So if anybody want to talk from Chicago to New York, yes, we can. And then we can have multiple branches, and like we built our routing table, okay? OSPF is classless protocol. Classless means, I have different types of routing protocols. Some protocols, older protocols, are classful, only work with class A, class B, class C default addresses, but OSPF will work with variable and subnet mask if you are not having a specific subnet mask. So that's why I'm saying classless routing protocol. Okay. And this will send your subnet mask with your all routes, so we can handle different classes. OSPF supports structured hierarchical design model using autonomous system. We have a backbone and other areas. What is autonomous system? Autonomous system represents your organization. So if you are having one network, so that is your autonomous system. Let's say we have a company working in North America, ABC LLC company. So that company have autonomous system, which is based in North America, also doing some business in Europe. So that is this company autonomous system. So OSPF basically work within a same autonomous system, and we can divide OSPF into multiple areas. We call it backbone areas and other areas, and that's what I'm going to show you. Okay, so this one is a basic introduction of OSPF. OSPF is link state open standard protocol, and how we can configure and how OSPF look like, that's what I'm going to show you. So here in this implementing OSPF, whenever you're gonna implement OSPF for multiple areas or for large organization, even medium-sized organization, so from where you're gonna start? You're gonna start from area 0. So this one is your backbone area, and that is your starting point. And later, if you really want to add any other areas, yes, you can add. Let's see, we are working in Europe, we are working in Asia. So if I want to add my branches over there, so I can add multiple areas. But while you are implementing OSPF, so this one is your starting point. You can start with area 0, and then you can add information. And if you guys notice here, we have LSA. LSA means link set advertisement. This is my link, and I'm gonna share my information with my neighbors. I have a neighbor, neighbor 1, neighbor 2. So these are my 2 neighbors. So what I'm gonna do, I'm gonna share that information with my neighbors. Let's see, if I have 5 routes, I can share that information with my neighbors. This is my neighbor number 1. This is my neighbor number 2. And once we share that information, neighbor will also share information with me, and this neighbor also share information. So then everybody is synchronized, okay? And this one is area 0, which is our starting point, okay? And you guys also remember, like I mentioned before, OSPF is interior gateway protocol. So this is basically work in a one autonomous system, okay? And the OSPF basically designed for medium to larger network, okay? And before OSPF, if we can go a little bit about history, we had RIP protocol, okay? And then after a RIP, we have OSPF, okay? So now OSPF is taking more, number of networks. Like when we started with a RIP, okay? Okay, guys, so now just 1 minute. So implementing OSPF, how we can implement OSPF, okay? So we can implement OSPF through areas. So first, if you wanna start OSPF implementation, so what you're gonna do, you're gonna start OSPF implementation with backbone area. This is my first area. We also call it area 0, okay? And whatever routers we have in this area, those are my backbone router, like router B, router D, router E, and router C. Once you build your backbone area, and then you can add other areas. And if you guys notice, this is my company autonomous system. We are working in different geographical location. Let's see, we are working in North America, Europe, Africa, Asia, and then you can start one more area in Europe, and then area 2 in Asia, area 3 in Africa. So I have a big autonomous system, and we have multiple areas. So right now we have 3 areas. If you guys notice, when we are running OSPF, so we are having our autonomous system routes, our addressing. But sometimes you are dealing with partners. Maybe your partners are using external routing domain. Maybe your partner is using another routing protocol, EIGRP, okay, which is Cisco proprietary protocol. And from there, we are getting routes. So those routes are coming from external world. Those routes are coming from partners. So those routes can also enter in your backbone area. And because of those routes, we can talk to our partner and partner can talk to us. And how it's possible, those routes can enter in your area through ASBR. This router have a one specific role. We call it ASBR. ASBR means Autonomous System Boundary Router. So this router brings routes from external routing protocol to your routing protocol and your route into external routing world. And this process also called route redistribution. That's what we're going to talk about. Okay, routes are entering from EIGRP, entering into OSPF, and routes are going from OSPF into EIGRP. And here we have another router, and this router have one interface is in area 1, other interface in area 0. So this router have 2 interfaces, one in backbone area, other one in area 1. So this router is ABR, area border router. So most of the time, whenever we configure area border router, we do route summarization also over here. Okay, and this one is also ABR, area border router, and that is also ABR, that is area border routers. So we are receiving routes from other areas like Europe, Asia, and Africa, and those routes are entering into our backbone area through ABR, and some routes we are getting from external, and that is possible through ASBR. So that is basic infrastructure of OSPF. Okay, and autonomous system, if you really wanted to know what is autonomous system, you are looking official definition. Autonomous system is a collection of networks, or in this we have multiple areas like area 1, area 2, area 0 under common administrations owned by your company. So we built this infrastructure first, we basically, and after that we really want to start our OSPF configurations. Okay guys, so right now we are just talking about implementing OSPF. So you guys always remember key point, first we always configure backbone area and then we add other areas. So that's the key point. Okay, now if you guys notice how we can do OSPF configuration, let's see. Let me take you to my previous slide. So let's see if I want to build neighbor relationship from router B to router C. So how we can do that? Neighbor relationship means whatever routes R1 have, R1 share with R2. Whatever routes R2 have, R2 share with R1. So then they can talk to each other and they can share other routes information also. So what you can do, you will go to R1, because how we can configure OSPF, you will simply connect to this router through console port, through SSH or Telnet, and then you go to global configuration mode, and then you type command router OSPF 1. Router means we are configuring routing protocol. OSPF 1 means this is our routing protocol. 1 means this is your process ID. So we are using router OSPF 1 on this router. And then we're gonna add our network information in this router. Whatever network we have, you're gonna add over there. And then you can go to other router. Here you are typing router OSPF number 10 is process ID. That is, you can notice over here. and over there we have process ID 1, and then we configure OSPF, and we provide network information of this router, we provide network information of that router, and after that these two devices build neighbor relationships. Hey R1, you are my neighbor. Hey R2, you are my neighbor. Once they establish neighbor relationships, after that they're gonna exchange all routes. Hey, I have 15 routes, and this guy say I have 10 routes. Let's synchronize those routes. Whatever routes you are missing, I'm gonna give you whatever route I am missing, you can share with me, and then they synchronize and they build neighbor relationships. So whenever we start OSPF process, we always start with this command router OSPF1, and we start OSPF process on R1, and then we start OSPF process on R2. Okay. So whenever you are building neighbor relationships, okay, so what you can do, you can go for, many things. Okay, this router say, hey, R2, I want to be your neighbor. So we basically have router ID, which is represent R1. We actually have hello and that intervals. This is router ID. This will just say this is my identification. We have hello and dead intervals. So by default, Cisco OSPF hello intervals are 10, dead intervals are 40. So we make sure those intervals should match if you want to be my neighbor. You can see here static sign. So if these things will match, so then we establish neighbor relationships. And then area ID, hey, you are in area 1, I'm in area 1, which is fine. Router priority, who wanna be a DR router, designated router, who wanna be backup designated router. So whatever router have a higher priority, that guy will be your designated router. And then whatever router have a second highest priority, so that will be backup designated router. What is designated router? Like in OSPF, if you have many routers, like let's say you have 20 routers in your area, so there is a designated router that is your main router. So whenever any change happens, goes to designated router, and this will update all other routers. If in case that designated router is not working, then we have a backup designated router. So whenever we make neighbor relationship, we really want to agree with those parameters. And then we're gonna go for authentication data. I want to make sure whenever I will talk to R1 to R2, R2 to R1, so we make sure these are two legitimate routers, and we exchange keys also. I don't want any hacker or cracker bring router and connect with my routers and grab my all routes. So that's why we need authentications. Okay. And sometimes you have a different types of area. If you want to configure stub area and both routers are in that area, then they're gonna make neighbor relationships. Okay. And you guys remember, whenever router build neighbor relationship, they always use multicast addresses, 224.0.0.5. So on this multicast addresses, these two devices basically communicate to each other. Okay. So here, now we are configuring OSPF for IPv4. Okay, this is my OSPF autonomous system, and that is another autonomous system. So we have two autonomous systems. In one autonomous system, we have area 0, and we have another autonomous system. We have area 0 and we have area 1. And like I mentioned, when routes are coming from one area to another, this device is called ABR. So that is our area border router. ABR can be configured to provide summarizations of routes between areas. Okay, so we do route summarization. Route summarization means I have, let's see, in area 1 right now we have a 3 router, maybe we have 50 routers. Instead of sending all routes to area 0, we summarize our routes and we send only summary route. In this way, our routing table will not increase. Okay, so that is route summarization. And then we are having another autonomous system. So whenever we are working with another autonomous system, we can also communicate, and those are external routes entering into our autonomous system. So we have a single area OSPF, This is multi-area OSPF, okay? Now, how we can configure? See, this one is R1. R1 have three interfaces. We have interface Ethernet 0/1, serial 2/0, Ethernet 0/0, three interfaces. And if you guys notice, one interface in area 1, other interface in area 2, and this interface is in area 0. So this guy is working as a ABR. So first of all, whenever you do OSPF configuration, this is number one step, configure OSPF. How we can do OSPF configuration? Like I mentioned, you simply go and type router OSPF and then process ID. And then once you configure OSPF, and then you're gonna go by DR and BDR, which one is designated router or backup designated router. This is totally depending upon your priority. And then we're gonna go for interface based configurations, okay? And then we're gonna go for step, after that interface based configuration, we're gonna go for neighbor relationships. OSPF built neighbor relationships on that interface with this router, on that interface with this router, on this interface on this router, and that router, okay? So, whenever we are running area 0 here, we are having an election, DR and BDR election, and who wins? Whatever router have a higher priority. So in this way, we configure OSPF routing for multi-areas. I can configure for area 0, area 1, area 2, okay? And you make sure whenever you do neighbor relationships, 3 parameters should match: authentication, hello and dead timers, and area ID, okay? Now, route distribution, route redistribution, what is that? Okay. Let's see, I'm working in my organization and we are running OSPF, and I have my partner and I really want to exchange routes from my partners because we are having business partnership, okay? And they are running business application. We really want to share routes so then those business applications can talk to each other, okay? So in this case, I cannot say to my partner, hey, we are using OSPF, you should go and use OSPF for your entire network because we are using OSPF. You cannot say that. So what is the solution and how we can communicate if my partner is using another routing protocol? Let's say you speak English, other one is speaking French. How you need communication? So answer is translation. So that's what we do here. We have OSPF this side, EIGRP on another side, and here we have R2 router, and this one is our ASBR for OSPF point of view. So this is ASBR, and this router is basically translate our OSPF route into EIGRP, and then EIGRP route into OSPF, okay? And this process is called route redistribution. So route redistributions allow routes from one routing protocol to be advertised in another routing protocol. That's what we talk about. And then while running a single routing protocol throughout your entire IP internetwork is desirable, multi-protocol routing is common for several reasons. That's what I was talking about, such as company mergers. You acquired company and they were using EIGRP before, so you cannot change in a one day from whole EIGRP to OSPF. So you need a route redistribution. So at least we can start our work, we can translate, and then later we're gonna change from EIGRP to OSPF. We have a multiple department managed by multiple networks, administrators, and multi-vendor environment. Running different routing protocol is often part of network design. So that's what I said, okay? Sometimes you are dealing with different types of equipments, and those equipments are working with particular routing protocols. So that is another reason. Sometimes you are working with one environment, like they don't want to use proprietary stuff. So maybe that's the reason, and your company is using proprietary stuff. So there are many reasons, and that's why we need route redistribution. Okay. Here we have example of route redistribution.
I'm going to pass this presentation over to Hassan, who is going to be telling you all about some of our fantastic promotions and webinar related courses. Okay, go ahead.
All right, Tracy, thank you. First of all, I would like to thank all of you for joining today's session. At NetCom, our purpose is to promote the values of lifelong learning. And as a result of that, NetCom on an ongoing basis is running various webinars and master classes in varieties of topics. So if you go to netcomlearning.com webinars, I'm pretty sure you're going to be able to see networking, cloud, application development, business process, to various aspects of learning and development. We primarily focus on IT space. So besides Cisco learning and development, just wanted to highlight our latest achievement. We've been nominated Microsoft Global Partner of the World in 2022. So it's one of the biggest achievements for any training company around the globe. So if you're exploring Cisco, AWS, Microsoft, or any major OEM, certainly would be able to assist you. So on an ongoing basis, you can go to webinar links and register for yourself. Another component that I think is worth looking into, you'd be able to find it on NetCom webpage, is called NetCom Plus subscription. And this subscription, it's technically speaking, one course you pay for and you attend all of the classes that comes with it throughout the entire year. So these are instructor-led live online classes and a lot of recorded contents that you would be able to have access to. So just want to highlight, if you go to that page where you would be able to see all across the board various domains from Adobe to Autodesk to CompTIA, EC Council, Microsoft, again, just to name a few, you'll be able to see all of the, and again, depending on your interest level, you can certainly sort through to see what you can get out of it. Now, the price, just want to quickly mention, it's a $3,000 per learner, but if you are representing an organization that has 10 or more learners, certainly would be able to lower that to $24.99. But if you have a larger group, would be able to cater that to even. So please do contact us for any inquiry. Lastly, I do want to highlight specific to Cisco, it's called Cisco CLC. Many of you are representing organizations that are sitting with Cisco Learning Credits or CLC. This is like a, money that you're sitting with that's going to expire after a certain period of time, and we'll be able to help redeem them at NetCom. As a Cisco authorized partner, your CLCs are good as gold, and every CLC, depending on the course that you might be interested in, from DevNet to Network Enterprise Data Center, Security Collaboration, or Service Provider, whatever the interest may be, from CCNA level to all the way to professional, even expert level, would be able to cater to you. So just want to bring it up. CLC is one of the ways to go. We have a dedicated landing page that you could specialize in depending on how many classes. So for example, as you can see here, administering Advanced Cisco Contact Center version 1.0, you can look at it requires about 28 CLCs. So it will guide you, but for any inquiry Cisco related or beyond, please do touch base with us. We have a dedicated learning consultants who can address any of your needs. And once again, thank you for joining the webinar. We look forward to seeing you in our upcoming sessions. So Tracy, back to you, and thank you for the opportunity.
Great. Thank you so much for all of that informative information. That was great. And now, Talib, we do have time for a few quick questions. So let's just get to this. First one from Edward. Why is OSPF called link state?
Okay, you know why we call it link state? In OSPF, we basically send link information. Whenever we have a router, hey, your link is up, your link is down, what is your link IP address? So we send that information to other router based on link, based on speed, based on link status. We basically take decision. That's why we call it link state, LSA. OSPF. Okay, so that's why we call it that.
Okay, one quick last question. What is matrix of OSPF?
Okay, very good question. OSPF will take decision based on speed, or we can say bandwidth. So if I want to prefer two routes, so which one I'm going to prefer? Whatever have a high speed, high bandwidth length. So that is OSPF metric. We call it also cost. So low cost means high speed length. So that is OSPF metric.
Perfect. Okay, we're just about out of time. We want to thank you, Talib and Hassan. In addition, we do have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register. We want to thank you all for joining us today. And if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We do hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.